In this video, let's discuss the important predicted concepts for this JEE Mains 2026 Jan Phase 1. This is my first predicted grand test paper 1 regarding chemistry subject. Without any delay, let's get into the topic now. The first question is based on Arrhenius equation. They have given a complex reaction here. EA1, EA2 and EA3 they have given, and they are asking us to calculate the activation energy for the overall reaction. As it is a complex reaction, total of 3 steps. In 3 steps the reaction took place, and they have given the relation also, right? So let us see how to solve this one. If we consider this particular Arrhenius equation, we know that K is equal to A into e power minus EA by RT, right? So they have given the relation K is equal to K1 into K2 divided by K3 whole to the power 2 by 3. Now let's apply the formula here. A into e power minus EA by RT. Let us say these are the A dash and EA dash, and we have to calculate the EA dash here. That's what they are asking for. And K1 is nothing but A1 A into, as it is the overall reaction, A into e power minus EA1 by RT into A into e power minus EA by RT, right, divided by A into e power minus EA3 divided by RT. Now let's apply the natural logarithm on both sides, but before that let's take that a power 2 by 3 common. After cancelling one a by a and a, here a dash is nothing but a power 2 by 3, right? A power 2 by 3. Then let's take out that a dash, that is equal to a to the power 2 by 3. Then you will get e power minus ea by rt and all. So let me write that one. E power minus ea dash by rt is equal to e power minus ea by rt. As powers are same, I'm just adding the, as the bases are same, I'm just adding the powers here. So ea1 minus ea1 by rt minus ea2 by rt and divided by here, as it is in the denominator, if it comes up you will get plus ea by ea3 by rt, right? Now I am going to apply the natural logarithm on both sides. If I apply natural logarithms on both sides, you will get minus ea dash by rt is equal to minus ea1 by rt minus ea2 by rt and then plus ea3 by rt, right? Which is nothing, after applying the natural logarithm here. This implies if RT gets cancelled out, you will have that EA dash as EA1 plus EA2 minus EA3. And here what we forgot here, it's 2 by 3 we forgot here. In fact, it comes before that. 2 by 3 factor comes before this particular EA1 by RT. So 2 by 3 into EA1 plus EA2 minus EA3. This is the formula to calculate the activation energy. So if we apply the values here, the activation energy EA dash, overall activation energy becomes 2 by 3 into EA1 means how much? 180 kilojoules plus EA2 80 kilojoules minus EA3 50 kilojoules. That means 2 by 3 into 80 minus 50 30, 30 plus 180 210, and here after the simplification you will get 140 kilojoules as the answer. So fourth one is the correct option, right? Let's move to the next question now. Cyanides, if we consider dibal H, which is a selective reducing agent, and here the dibal reduces the cyanides, that means nitriles, into aldehydes but not amines, and we know that imine is the intermediate that is going to form when the cyanides are attacked by this particular selective reducing agent, and here the intermediate is nothing but the imine, which is nothing but CH double bond NH, which on hydrolysis, the cleavage of double bond, where you are going to get two OHs here, and the removal of water molecule readily converts into this aldehyde group, and where the byproduct is ammonia, right? So which is the correct option here? The first one is the correct option, right? Next one, select the correct statement. The first one, if the molecule has any polar bond, then it is always polar. Select the correct statement. If the molecule has any polar bond, then it is always polar. No, though some molecules are having polar bonds, they do not they are not polar in nature, because whenever the molecules with the symmetry, for example, if we consider XeF4, though it is having that polar bond, as it is having that square planar structure, all the dipole moments will be cancelled out, so that you will get that mu value as 0, which is a non-polar. So symmetrical molecules with polar bonds are non-polar in nature, hence the first option is the wrong statement. And what about ClF3? ClF3 is planar. No, ClF3, if we consider, it is having that T shape, T shape, two vectors cancel out, but definitely this vector quantity of dipole moment will not cancel out, so mu not equal to 0, which is a polar molecule. And if we consider the bond angle order of hydrides of 50A group elements, if we consider the central atom, all the central atoms are having the lone pair of electrons. Smaller the central atom, longer will be the bond angle, and hence NH3 bond angle is more when compared with PH3 and ASH3 and SPH3. So here the bond angle decreases down the group, but they have given increasing order, which is again the wrong option. So all the first three are wrong. And what about this one? XCF6 has a distorted octahedral geometry. Yes, definitely it has that one lone pair of electron, which distorts the octahedral geometry, and hence XCF6 has distorted octahedral geometry. Fourth one is the correct statement. 6.023 into 10 power 23 molecules of CaOH twice react with 3.01 into 10 to the power of 22 molecules of HCl. Number of moles of CaCl2 obtained are. So this question is based on the stoichiometric calculations. Immediately we need to write the balanced equation between CaOH twice and HCl. So CaOH twice plus 2HCl will give you CaCl2 plus 2 moles of H2O, right? Here, the 6.023 into 10 power 23 molecules means 1 mole. They have taken 1 mole of COH twice. And here 3.01 into 10 to the power of 22 molecules of HCl means if it is 23, we would have written 0.5 moles, right? But they have given 10 power 22, that means 0.05 moles only they have taken that HCl molecule, HCl. Okay, then how many moles of CaCl2 will be obtained? For 2 moles, we know that it is 1 mole of CaCl2. But for 0.05 moles, because here the limiting reagent is this HCl, so based on the limiting reagent only we need to expect the product. For 0.05 moles, how many moles of CaCl2, which we get as 0.025 moles of CaCl2, right? So the correct answer is 3. Here, assertion is atomic radius of gallium is higher than that of aluminum. No, if we consider the radius of gallium, it is in fact slightly less when compared with the radius of aluminum. It is because in the gallium, whatever the additional 3d10 electrons are present, they show the poor shielding effect, and hence the inner shell electrons experience more effective nuclear charge than expected, and hence the gallium radius is less than aluminum. Let's check the reason here. The presence of additional 10d 3d electrons offer poor shielding effect for the outer electrons. Yes, for the outer electrons, and increases the nuclear charge in the gallium, right? The reason is definitely right, but because of this reason, the gallium should have a less atomic radius, will be having the less atomic radius than the aluminum, but they have given higher than aluminum. So assertion is false, and the reason is correct, right? Very important, the fundamental question, this one in 3A group elements. Consider the following reactions. Here A is giving the PPT with Ag2O, must be a terminal alkyne, at least one terminal hydrogen must be there in order to get the silver white precipitate. And here in this particular question, the clue is here. If we consider the turbidity within 5 minutes, Lucas reagent, with this Lucas reagent test, we know the secondary alcohols readily give, the turbidity not readily give turbidity within 5 minutes, right? So it must be a secondary alcohol. And NaBH4, so C must be a secondary alcohol. C must be secondary alcohol means with a selective reducing agent, ketones only will give you the secondary alcohol. We are getting ketones, right? So we are getting ketones here with the A, which is an alkyne here. The oxymercuration and deoxymercuration is giving the ketone means definitely it is not acetylene, because glycols you will get with acetylene, which is aldehyde group. So it must be alkyne with one terminal hydrogen, that means the second one is the correct one. Let us see the reaction here, the complete reaction. See, if A is a CH3C triple bond CH with the Ag2O, definitely this particular hydrogen will be replaced with the Ag, you will get a silvery white precipitate here. And again that same CH3C triple bond CH on Hg2 plus H2SO4 oxymercuration, deoxymercuration, you will get acetone here, right? Acetone with sodium borohydride, you will get a secondary alcohol which is nothing but a CH3CHOH CH3, which readily gives I mean which readily which gives sorry which gives the turbidity within 5 minutes with a Lucas reagent, ZnCl2 and concentrated HCl. So the correct answer is the second one. It's a matching question based on hydrogen spectrum. They have given simply the lines of different series of lines, and they're asking us to predict the n values. Okay, Lyman series, if we consider, we know the transition is to n is equal to 1. As it is the first line, definitely it is n is equal to 2 to 1. So a is connected with 3, and the second line of Balmer series, second series, so n is equal to 2. As it is the second line, n is equal to 4 to n is equal to 2 is the transition. And similarly, the first line of Balmer series is definitely 3 to 2. So C is connected to 2. And the second line of Lyman series, which is again from 3 to 1, related to the first one. Simple matching question, and the fourth one is the correct one. Next question is from D and F block elements from lanthanides. Here they have given statement type question. The statement 1 is the actinoids show Ingen plus 3 oxidation state. Yes, of course the statement 1 is correct. Both the lanthanides and actinoids show general plus 3 oxidation state. And what about statement 2? Actinoid contraction is greater from element to element than lanthanide contraction. It is also true. In fact, if we consider the 5f electrons and 4f electrons, 5f electrons have a more poor shielding effect. Because of the poor shielding effect, we know the contraction takes place, and that poor shielding effect is more in case of actinoids due to that 5f electrons when compared with the 4f electrons. So generally, though the lanthanide contraction is famous, but in fact the contraction is more in case of actinoids from element to element, and hence the statement 2 also correct. And here you need to be very careful while selecting the option where the statement 1 and 2 are correct, and hence the third one is the correct option. The next one is a simple one based on the physical states. They are asking for a liquid metal and a liquid non-metal example. We already know about the liquid metal, right? So mercury is a liquid metal. And what about liquid non-metal? Right, reddish brown or reddish orange liquid is of bromine, which is a non-metal. So liquid non-metal is bromine, and mercury is a liquid metal, and hence the third one is the correct one. Next one, a series of reagents they have given and asking us to predict the final product here. And here the clue in the question is of the sodium in presence of dry ether. By looking at the phenyl group and the sodium in presence of dry ether, fatigue reaction. So definitely the compound must be this one, right? The biphenyl compound. So one can easily predict the second one is the last product. And let's check once here. C6H5NO2 and FeHCl, and so the nitro group undergo reduction, and you will get the NO2 group converts into NH2 group. NaNO2HCl, diazonium chloride will be formed, N2 plus plus Cl minus. The aniline undergo the diazotization in presence of this particular 0 to 5 degree centigrade HNO2 reaction. Diazonium chloride, the Gutterman reaction with copper, you will get chlorobenzene here. So definitely the C must be a chlorobenzene, because aryl halides only undergo Fittig reaction. That's how we can easily predict with the help of this sodium in presence of dry ether, and the final product is biphenyl, right? Which is which involves a lot of reactions here, the named reactions and very important reactions only, so we can easily predict the product. Next question is the combination of chemical kinetics, that is like not the kinetics, in fact it is equilibrium. Next question is the combination of equilibrium concept and the coordination compounds. And generally the stability constant of a complex is nothing but the rate constant of that particular uh, reaction, the particular reaction. And we know that and what they have given, see here, for this reaction rate of forward and reverse reactions they have given. So rate of forward at equilibrium, if we consider Rf is equal to Rb, and in fact Kf by Kb will give you the equilibrium constant, which is nothing but the stability constant for a complex. And here if we observe this one, this Kf and this is Kb, so just by substituting these two values here, this 1.45 into 10 to the power of 13 divided by 1.22 into 10 to the power of minus 4, we get the answer, the value as 1.18 into 10 to the power of 17, and hence the correct answer is 3. Next one is from the coordination compounds. Which of the following is expected to be paramagnetic complex? We know that the central metal ion, if it has unpaired electrons, then it is a paramagnetic complex. If it does not have any unpaired electrons, it is diamagnetic in nature. Let's have a look at the central metal ions in each case. If we consider the first one, Na plus 2 is the complex, the metal ion where the configuration is 3d8. As H2O is a weak ligand, there are two unpaired electrons in the central metal ion. Hence, it is paramagnetic in nature, weakly attracted by the external magnetic field. Then what about the remaining? Of course, the first one itself is the paramagnetic complex. Let's check the remaining also. In the case of second complex, Zn plus 2 is the configuration, and where the 4s0310 is the configuration, all are paired electrons. And in the case of third complex, NiCO4, nickel, the zero oxidation state, 4s3d8 is the configuration. In the presence of a strong field ligand like CO, the two electrons will be paired up here, so that it has zero unpaired electrons, hence diamagnetic. In the fourth case also, the CO plus 3 configuration, 4s0 3d6 configuration, the strong ligand like NH3 pair up the electrons when it approaches the central metal ion, and hence the fourth complex also the diamagnetic in nature. So it's a quite easy one, but important concept, and the first one is the correct answer here. Next one is again a matching question from solutions chapter, especially on the Van 't Hoff factor. We know that I is equal to 1 plus n minus 1 into alpha. Alpha is the degree of dissociation. And delta TB, they are asking to match with that list 2. If we consider the urea, it is a non-electrolyte. So I is equal to only 1 for a non-electrolyte. And delta TB is equal to 1 into Kb into M. That's what, as molality is 1, we can say that delta TB is equal to Kb for the first one. So directly 1 matches with the P here. And what about the second one, KCl? two ions will be liberated for each molecule, so n is equal to 2 here, and I is equal to 1 plus 2 minus 1 into 100%, that is alpha is 1, and where we are getting I is equal to 2, and hence delta TB is equal to 2 into KB. Second one is matching with the R here. Similarly, for the third one, the number of ions per one molecule is 3, and I is equal to 1 plus 3 minus 1, that is 2 into 75%, that is 0.75%. uh, 2 into 0.75 is nothing but 1.5, and 1.5 plus 1 is nothing but 2.5, so 2.5 kb. So third one is matching with the, yes, obviously if we do the fourth one it matches with the Q, and hence the first one is the correct one. So if we know the fundamentals and if we know the formulae of all important concepts, it's very easy to solve this type of questions, right? The next question is from group 14 elements regarding carbon and silicon. Carbon and silicon belong to the group 14. The maximum coordination number of carbon is 4, whereas for silicon it is 6. This is due to, it's a simple question. If we consider the carbon, carbon has the configuration 2s to 2p2, where there is no 2D subshell in order to expand its covalency. Whereas in the case of silicon, the configuration 3s to 3p2, and it has a 3D subshell also, so it can expand its covalency up to 6, and hence the carbon valency is 4, whereas the silicon valency is 6. So the answer is availability of d orbitals in the silicon. They have given two statements. Statement 1, DNA does not contain uracil. Yes, RNA contains uracil. RNA contains uracil, whereas DNA contains thymine, right? So statement 1 is correct. And what about the statement 2? If we consider that enzyme that catalyzes the hydrolysis of maltose into glucose is named as maltase. Yes, maltase is an enzyme where we get glucose from maltose. Every enzyme has its own specific biochemical reaction, and statement 2 also correct. Hence both the statements are correct. Answer is third one. Right. The next question is based on the redox reactions. Here the chromate ion is oxidizing the thiosulfate ion into sulfate ion, and they are asking for the number of milliliters of 0.154 m of chromate ion. Here one should able to write the balanced equation between chromate ion and this S2O3 minus 2 ion in the basic medium especially. So 4CrO4 minus 2 requires 1 mole of H2O3 minus 2 to oxidize, so that chromium ion converts into CrOH of 3 times, and here 2SO4 minus 2 ions in the presence of a basic medium. Okay, anyhow here they are asking the relation or the number of moles between the CrO4 minus 2 and H2O3 minus 2. 4 moles require 1 mole of H2O3 minus 2. But regarding chromate ion, they have given, if if let us suppose that x milliliters of 0.154 molar is reacting, in that case 0.154 x moles requires um, this H2O3 minus 2, regarding H2O3 minus 2, number of millimoles will be 0.246 into 40, where if we calculate, if we do the cross multiplication here, you will get x as 170.4 milliliters. Okay, this type of questions you need to write the balanced equations. Otherwise we can go for um, the number of equivalents also, where we need to understand that chromium oxidation state changes from plus 3 to plus 6 to plus 3, and H2O3 minus 2 changes from plus 4 to plus 6. Okay, anyhow the answer is 170.4 milliliters. Next question is from practical chemistry, especially the um, salt analysis, and they are asking from the cations group reagents. Very, very important for mains point of view. Don't neglect the practical chemistry. In your plus 2 or intermediate second year practicals also you come across this particular reaction. Let us read the question first. A solution containing group 4 cation gives a precipitate on passing H2S and dilute HCl. Yes, fourth group reagent is dilute HCl and H2S, and we have zinc and nickel in that. White precipitate with NaOH solution means definitely it is Zn plus 2 ion, because it readily forms a zinc hydroxide turbidity, which is a white precipitate, and it also forms a bluish white precipitate with potassium ferrocyanide, which is nothing but K4FeCN of 6 times. When the zinc reacts with it, it readily forms Zn2FeCN of 6 times, which is bluish white in color, and hence Zn plus 2 is the correct one. Group reagents as well as the confirmatory tests of both cations and anions are very, very important for mains entrance examination. Okay, go through it once. Let's move to the next one. This type of questions are very, very important. Very important concept. Here they're asking for the most basic nitrogen in the following compounds. How to solve this type of questions means, look for the free lone pair of electron on the nitrogen. The one which readily gives the lone pair of electron is more basic in nature. For that, the lone pair must be free. It must not involve in either resonance or in aromaticity. Suppose if we consider the first one, it is involving in the aromaticity. The second and third one, if we consider, there is a C double bond O, where there is a chance of conjugation or resonance. But in the case of this pyridine nitrogen, where the lone pair of electrons on the pyridine, on the nitrogen of the pyridine, are not involving in the resonance, hence it can easily donate when compared with the remaining three. So answer is the third one. The one which readily donates the lone pair of electron, nitrogen, is said to be more basic in nature. It must be free from the different electronic effects. Okay. And the least basic is one which involves in the aromaticity. That is the first one. Okay. Now let's move to the next one. It is based on the common ion effect concept. Here they are asking for the solubility of AgCl in water, H2O, 0.01 molar CaCl2, NaCl and AgNO3. Among all these four solvents, H2O does not contain any common ion, hence the solubility is more in the case of water. Definitely S1 is greater than all these three, because all these three contain the common ion with that of AgCl. And if we consider this NaCl, Cl minus ion concentration is 0.01 molar with only one ion in the NaCl. So common ion is there, and with low concentration we need to check, because whenever there is a common ion the solubility decreases. So less concentrated common ion solvent, if we consider the solute solubility is more, and hence if we consider the Cl minus, only one Cl minus ion is there, so 0.01 molar, which is less when compared with 0.05. And what about this one? There are two Cl minus ions, and hence the Cl minus ion concentration will be 0.02 molar, where the common ion is more concentrated when compared with the third one. And if we consider the less concentrated common ion is third one, and hence S1 greater than S3. Among these two, less concentrated is this one, so you can say that S2 and then S4. So the solubility based on the common ion, which is nothing but common ion effect, less concentrated common ion solvent, if we consider in that particular solvent the solubility of a electrolyte is more. That is the main principle involved in this particular question. Okay, assertion reason type question. uh, in this, the assertion is the Lucas reagent is a mixture of anhydrous ZnCl2 with concentrated HCl. So Lucas reagent, where primary alcohols do not give immediately the precipitate, it takes almost 30 minutes. If we consider the secondary alcohol, turbidity is formed in 5 minutes, whereas tertiary alcohol gives readily the turbidity, right? But they are giving the reason as primary alcohol produces precipitate with Lucas reagent immediately, so which is a wrong statement. Assertion is definitely true. Lucas reagent is concentrated HCl and anhydrous ZnCl2. So answer is A is true but R is false. It's a regular concept, but we should be very clear about, we should not have any confusion whether the primary alcohol is giving the immediate turbidity or tertiary alcohol. When we are sure of each and every concept, then only we avoid the negative marks, right? So anyhow, which is here we have a easy question, but some students may confuse between primary or tertiary alcohols, and primary alcohol do not give the turbidity immediately, almost takes 30 minutes, whereas tertiary alcohol gives turbidity immediately, right? With this, we completed the multiple choice questions. Let's go to the integer type questions of this grand test 1. By the way, if you are feeling that this particular video is helpful for you, please like, share and comment. The question is from thermodynamics. The 1 mole of ideal monoatomic gas is heated according to the path AB. So if we observe the AB, it is a isobaric process since the pressure is constant, and AC, if we consider, it is not a straight line either to pressure axis or volume axis. You can say that it's a polytropic process where P is equal to Kv. For AC type reaction, P is equal to K into V. And of course, AB is isobaric process, right? And in the case of molar heat capacity, if we consider molar heat capacity for a like AC process, if we consider, it is nothing but 2R, which is of Cv plus R by 2, nothing but 2R molar heat capacity for process AC. And for process AB, if we consider, it is nothing but uh, 5 by 2 R, where we get the Cp, the integration of Cp within the range dt and integral Cm within the range dt, if we consider, you will get 2 by 2r here, and here you will get 5 by 2r. And they are asking for QAC by QAB into 10. QAC nothing but 2R, and here if we consider, sorry, here if we consider the AB process, it is nothing but 5 by 2 R into 10. So R and R gets cancelled. 4 by 5 into 10. Then you get 8 as the answer. So integer 8 is the correct answer for this question. Okay. Next integer. How many compounds have 2 sigma and 2 pi bonds? If we consider the calcium carbide, there is a triple bond in the carbide ion, C triple bond minus C2 minus 2 ion. And if we consider the Mg2C3, there is 2 double bonds, that means 2 sigma bonds, and 2 uh, pi bonds are there in this Mg2C3. And in the case of CaCN2 also, we have two double bonds between carbon and nitrogen, where it gets that minus 2 charge. And obviously the aluminum carbide also contains a triple bond between two carbon atoms, but not 2 sigma and 2 pi bonds. Okay, so these two are having both 2 sigma bonds and 2 pi bonds. Total 2 compounds we have with the required condition, right? So hence the in the case of integer type answer, 2 is the answer for this 47 question. In the given reaction, they are asking for the number of sp2 hybridized carbon atoms, number of sp2 hybridized carbon atoms present in the one molecule of the end product jet. So let's predict the product first. NBS, N-bromosuccinamide, meant for the allylic bromination. The allylic carbons are here and they have taken excess, so you can say that both the hydrogens in both the cases are substituted by the bromines. Hence you will get a Br here and here also Br, the same case here. And after reacting with the KOH, where KBr will be eliminated and aqueous KOH substitution takes place, and two OH groups uh, leads to the elimination of water molecule by heating, and we can say that the final jet product is nothing but this one. In this, how many sp2 carbon atoms are there? Carbon with double bonds, there are all 6, 7 and 8. Total 8 carbons are there with the sp2 hybridization, and hence the answer is 8. Next integer question from the electrochemistry chapter, based on Nernst equation. Here the EMF of the cell they have given as a 0.28 volts. Calculate the pH of the solution at the hydrogen electrode, and they have given E naught of Zn also. So for this type of questions, first we need to calculate E Zn by Zn plus 2, which is nothing but E naught Zn by Zn plus 2 minus 0.059, that is 0.06 by 2 into log Zn plus 2 concentration, which is 0.1 divided by Zn concentration, which is taken as a unity. And here you, if you substitute the value here, you will get 0.06 divided by 2 into log 10 power minus 1, where we are going to get as a positive sign here, and this is 0.03, so the answer will be 0.79 volts, right? And the EMF of both zinc electrode and hydrogen electrode, if we consider, the electrode potential of H plus and H2, if we consider, it is nothing but minus 0.06 pH. We have a direct formula. direct relation between E and pH. So for the total reaction, if we consider the total electrode potential is 0.28, so this we get by subtracting the E Zn by Zn plus 2, the which is nothing but 0.79 volts, and this EH plus, that is nothing but minus 0.06 pH. Okay, so from this we can easily calculate as 0.06 pH is equal to 0.51, from which we can calculate the pH as 8.5. Okay, so 8.5 is the answer. And in general, in the case of integer type questions, one must take the sorry, the audio got disconnected, and here they are saying that report your answer by multiplying with 2. So 2 into 8.5, 1 minute, yeah, 2 into this 8.5, if we consider, you will get 17 as the answer. So 17 is the answer for this question. Okay, next one, last one, from organic chemistry, which is an easy one. Here they are asking for the molecular weight of Z in gram per mole. So let's first predict the product here. NO2 with SnHCl, we know that it readily converts into NH2, which is a aniline. We know already the diazotization, NaNO2HCl, you will get a benzene diazonium chloride here. Whenever the benzene diazonium chloride undergo hydrolysis, we get phenol as the product. So here the final product is phenol, where 94 grams is its molecular weight. So answer is 94. So how is the session? And I hope I covered very important topics related to JEE mains. Thanks for watching the video. Thank you.